Hello viewers, in this video lecture we are going to see about how to design a FIR band reject filter for length 7. For the cutoff frequencies given as lower cutoff frequencies as 3 kHz and higher cutoff frequencies as 5 kHz. The sampling frequency is given as 20 kHz. Determine the filter coefficient using Hamming window. Assume the filter to be an causal. So for this problem, here the given cutoff frequencies. Here the given cutoff frequencies is in frequency. You have to convert into radian per second. That is step 1. That is the conversion. That is a plot the response. Step 1 is plot the response. Here the cutoff frequency is given as, let it be, omega C1 is equal to 3 kilohertz. Sorry. Let it be the lower cutoff frequency be F1 and the upper cutoff frequency be 5 kilohertz. From this you have to find the cutoff frequencies which should be in radian per second. That is omega C1 is equal to 2 pi into 3 into 10 power 3 divided by the sampling frequency is given as Fs is given as 20 kilohertz divided by 20 into 10 power 3. So you just solve it. By solving you will be getting 0.3 pi, and similarly the upper cutoff frequency is 2 pi 5 kilohertz 5 into 10 power 3 divided by 20 into 10 power 3, and this is 10, this one cancel, 22 divided by 20 is 10, so that 0.5 pi. So we convert the given frequencies into radian per second. So from this plot the response. That is the frequency is between minus pi to plus pi, and the lower cutoff frequency is 0.3 pi. The upper cutoff frequency is 0.5 pi, and similarly minus 0.3 pi and minus 0.5 pi. Here it is a band stop filter for the frequencies between 0.3 and 0.5. That is, you don't have the signal between 0.3 pi and 0.5 pi. So for other frequencies you will be having the signals. So this is the graph of band reject filter or band stop filter. It is not an ideal filter. It is not an ideal filter. That is HD of e power j omega is equal to, it is symmetrical about, you have the maximum magnitude at n is equal to 7. So that e power minus j, 7 minus 1 divided by 2, that is e power j into 3 omega. Next, so we identify it is a type of it is a band stop filter. Next we are going to solve to find the desired response by taking the inverse DFT for the given response. That is desired response. So desired response HD of n is equal to 1 by 2 pi integral minus pi to plus pi HD of e power j omega. That is HD of e power j omega into e power j omega n into d omega. This is equal to 1 by 2 pi. Here from the plot the response is first is a low pass. First that is addition of the low pass filter and the high pass filter is between minus 0.3 pi to 0.3 pi. That is HD of, that is e power minus j 3 omega into e power j omega n into d omega plus minus, that is 1 by 2 pi minus pi to minus 0.5 pi e power minus j 3 omega into e power j omega n into d omega plus 1 by 2 pi integral 0.5 pi to pi e power minus j 3 omega into e power j omega n into d omega. That is 1 by 2 pi minus 0.5 pi, sorry, 0.3 pi to 0.3 pi. I am taking j omega common outside, that is n minus 3 into omega into d omega plus 1 by 2 pi integral minus pi to minus 0.5 pi e power j into n minus 3 into omega into d omega plus 1 by 2 pi integral 0.5 pi to pi e power j n minus 3 omega into d omega. So after applying the upper limit and the lower limit, the final answer is, so you know that sine n pi, here the n is n minus 3, the pi value is 0.3 pi divided by n pi, that is the n minus 3 into pi. And for high pass sine n pi, n minus 3 into pi divided by n minus 3 into pi, and then the low, that is the sine n pi minus sine n pi minus sine n minus 3 into 0.5 pi divided by n minus 3 into pi. So that the final answer is sine n minus 3 into 0.3 pi plus sine n minus 3 into pi minus sine n minus 3 into 0.5 pi divided by n minus 3 into pi. So we found the desired response HD of n. You just add the response of the low pass filter and the high pass filter, you will be getting the response of the band pass filter. Very simple. The low pass filter is 0.3. So here the n value is n minus 3. So sine n minus 3 into 0.3 pi plus sine n minus 3 into pi minus sine n minus 3 into 0.5 pi divided by n minus 3 into pi. So in this way you have to find the desired response. Next we are going to find the actual response. That is the step 3. Step 3 is actual response. Actual response or impulse response. The actual response has been found by taking the product between the desired response and the Hamming window function. For the length n is equal to 7, so n value is equal to 0 to n minus 1 by 2, that is 0 to 2, so n is equal to 0, 1, 2 and 3. Then find, for different n values, find the desired response. For HD of 0, substitute 0 in as that is HD of n is equal to sine n minus 3 into 0.3 pi plus sine n minus 3 into pi minus sine n minus 3 into 0.5 pi divided by n minus 3 into pi. So for different n values, that is HD of 0, for HD of 0, substitute n is equal to 0 here, the HD of 0 value is 0.1388. Keep your calculator in radian mode to find the value for different n values 0, 1, 2 and 3. For HD of 1, which is 0.1513, and HD of 2 is equal to minus 0.0607, and HD of 3 is equal to 0 by 0. When you put n is equal to 3, sine 0, 0, 0, 0 by 0, it is indeterminate value. Indeterminate value. So to find the value for n is equal to 3, you have to apply L'Hospital rule. At n is equal to 3, that is limit n is equal to 3, differentiate numerator and denominator with respect to n, so that My answer, differentiate numerator and denominator with respect to n. That is n minus 3 into 0.3 pi plus pi into cos n minus 3 into pi minus 0.5 into cos n minus 3 into 0.5 pi divided by with respect to n, so that it is pi. So put n is equal to 3. So cos 0 value is 1. So the answer is 0.5 pi plus pi minus 0.5 pi by pi, which is equal to 0.8 pi. 1 minus 0.5, it is 0.5, 0.5 plus 0.3, 0.8 pi by pi is equal to 0.8. For HD of 3 is 0.8. Next, you have to find the window functions. That is, the window function is Hamming window. That is, Wm of n is equal to 0.54 plus 0.46 into cos 2 pi n divided by n minus 1, that is 6. It is equal to 0.54 plus 0.46 into cos pi n by 3. Okay, for applying the different n values, you have to find the function for different n values. Wm of 0, for 0 the value is 1. Wm of 1, the value is 0.77. Wm of 2, the value is 0.31. Wm of 3, the value is 0.08. Here it is not an ideal filter, and it is not symmetrical about 0, so that you have to shift the window function 3 times to the left, or write the window function in reverse order. That is, Wm of 0 is equal to 0.08, Wm of 1 is equal to 0.31, Wm of 2 is equal to 0.77, Wm of 3 is equal to 1. So don't forget to write in reverse order for non-ideal filter and the filter which is not symmetrical about 0. Okay, so this is a very important step. Then you have to multiply with the desired function hd of n into wd of n. So h of 0 is equal to hd of n into wd of n. You just multiply hd of 0 into wd of 0. The value is equal to 0.011, and h of 1, similarly for h of 1, 0.0469, and h of 2 is equal to, multiply this, minus 0.0467, and h of 3 is equal to 0. So we have found the filter coefficient for desired response on the window function. Next step is we have to find the transfer function h of z, which is in non-realizable form. The relation to find this h of z is equal to h of 0 plus summation n is equal to 1 to n minus 1 by 2. N minus 1 by 2 is 6 by 2 is 3. H of n into z power n plus z power minus n. This is equal to h of 0, that is 0.011 plus 0.0469 into z power 1 plus z power minus 1 minus 0.0467 into z power 2 plus z power minus 2 then plus 0.8 into z power 3 plus z power minus 3. So we have found the filter function which is in non-realizable form. Next we have to find the transfer function for realizable form. That is h of z bar that is a realizable form or for causal filter. That is h of z bar is equal to z power minus n minus 1 by 3 into h of z. This value is equal to 0.011 z power minus 3 plus 0.0469 z power minus 2 plus z power minus 4, and then minus 0.0467 into z power minus 1 plus z power minus 5, and then plus 0.8 into z power 0 plus z power minus 6. So this is the transfer function which is in the realizable form. Next, the last step is we have to find the filter, that is the frequency response. Step 6 is frequency response. To find the frequency response, know the relation h of e power j omega is equal to a of 0 plus summation n is equal to 1 to n minus 1 by 2 into a of n into cos omega n. A of 0 is equal to h of n minus 1 by 2. A of n is equal to 2 into h of n minus 1 by 2 minus n. So a of 0 is equal to n minus 1 by 2 is 3. So h of 3. So what is the h of 3 value? So h of 3 value is 0.8. A of 1, that is 2 into h of 2. 2 into h of 2. 2 into minus 0.42467, and it is equal to minus 0.0934. And then a of 2 is equal to 2 into h of 1 is equal to 0.0938. And then a of 3 is equal to 2 into h of 0. H of 0 is 0.011. 2 into this 0.0222. So from this, the frequency response as h of e power j omega is equal to a of 0.08 minus 0.0934 cos omega plus 0.0938 cos 2 omega, and then plus 0.0222 cos 3 omega. So this is the actual frequency response for the band reject filter. Let me brief about the problem which we analyzed. That is, we have to design a band reject filter. Here the filter is not symmetrical about 0, and it is not an ideal filter, and the parameters are given in the hertz. So we have to convert into radian per second. After converting it into radian per second, that is the 2 pi fc divided by fs, that is the sampling frequency, and then draw the plot. That is for upper cutoff frequency is 0.3 pi and lower cutoff frequency is 0.5 pi. So 0.3 pi, so that is the band stop or band reject filter for 0.3 pi and 0.5 pi. That is, you don't have the signal between 0.3 pi and the 0.5 pi. So for remaining frequency you have the signal. So after by taking the inverse Fourier transform, from the graph it is easy to find the actual response. This is a low pass filter, that is a band stop filter is nothing but addition of low pass filter and the high pass filter. For low pass filter it is sin n minus, it is not symmetrical about 0, it is symmetrical about 3, that is e power minus j 3 omega, that is at that point you have the maximum amplitude, e power minus j 3 omega, that is n minus 3. So sin n minus 3 0.3 pi plus sin n pi. Sin n is n minus 3. So sin n minus 3 pi minus sin n minus 3 into 0.5 divided by n minus 3 pi. So you have to find the, from this you have to find the desired response. Next you have to find the actual response. The actual response is, so you have to design the FIR filter by using the Hamming window. So HD of n into a Hamming window for n is equal to 7. So n is equal to 0, 1, 2 and 3. And then find the HD of n value for n is equal to 0, 1, 2 and 3. So for n is equal to 3, it is an indeterminate value. So you have to apply the L'Hospital rule. Differentiate numerator and denominator with respect to n. And substitute n is equal to 0, you will be getting 0.8. Next, apply the Hamming window. 0.54 plus 0.46 into cos 2 pi n by 6 is equal to 2 pi n by 3. And then find the value for different n values 0, 1, 2 and 3. So 1, 0.77, 0.31 and 0.08 for n is equal to 0, 1, 2 and 3 respectively. Here the filter is not symmetrical above the 0, it is symmetrical above 3. So I just shift the window function, that is the window coefficients 3 times to the right or right in the reverse order. So both the operations are same. I am writing in the reverse order. Wm of 0 is equal to 0.8, 0.31, 0.77 for a Wm of 3 is 1. Just multiply it. Don't forget to reverse the window coefficient if the filter is not ideal. Okay. So after multiplication, find the transfer function. Here for non-realizable form, h of 0 plus summation n is equal to 1 h of n into z power n plus z power minus n. And for realizable form, multiply by z power minus n minus 1 by 2 into h of z. So this one is the transfer function which is in realizable form. Next, find the frequency response. So a of 0 plus summation n is equal to n minus 1 by 2 a of n into cos omega n. A of 0 is equal to h of n minus 1 by 2, 2 into h of n minus 1 by 2 minus n. So a of 0 is equal to h of 3. After finding all the values, apply this filter coefficient to find the frequency response. 0.8 minus 0.0934 cos omega plus 0.0938 into cos 2 omega plus 0.0222 into cos 3 omega. Okay. Next, so I'll giving you one small problem. That is, you take it as an assignment. That is, the function is e power minus j 3 omega for the frequencies from minus pi by 4 to pi for 0 for other frequencies. That is pi by 4 less than or equal to omega less than or equal to pi. So by using Hamming window with n is equal to 7. Post the answer in the comment section. For more problems, subscribe our channel. Thanks for listening. Thank you so much.